Hi, first hour and fourth hour. I'm showing you what I'm going to put on Google Classroom. It might be a good idea to pause this video and make sure you have a copy of this. By that I mean either download it and print it off your printer or copy these problems in your notebook. Your homework is to complete the entire sheet. I'm going to do the first row together, so if you want to do it with me, you can copy the answers. I'll pause so that you can stop this video and complete the identical problem with different numbers. That'll be great practice for our test on Friday, the Exponent Gateway, which will have problems exactly like this in a different order with different numbers. I'm ready to start. Let's start with problem number 1. Take a look at that. I see 10x to the negative fourth. The skill we're looking at here is to make sure that we can say 10 times x to the negative fourth and understand those are two separate terms. Now remember negative exponents. Exponents multiply things over and over and over again. Negative exponents are the inverse, so they divide things over and over and over again. So whenever I see a negative exponent, the first thing I do is make a bar, because I know somebody is going to cross the bar. The 10 has a positive exponent of 1, so it stays in the numerator. X to the fourth moves into the denominator, and when the exponent crosses the bar, it becomes positive. Take a minute to do problem number 1. Welcome back. Problem number 2, the power property. You might know the shortcut on how to do this. I'm going to do it the long way the first time. When I look at this problem, I see x squared to the cubed. The cubed means something times itself 3 times. So I'm going to write that out, x squared times x squared times x squared. And I have a total of 2, 4, 6 x's. The answer to this is x to the 6th. Try the power property on your own. Welcome back. The next problem is a fraction raised to a negative exponent. Negative exponents make fractions turn into reciprocals. Here's how. The first thing I notice is that there are parentheses. I'm going to break this fraction apart and say 2 to the negative 2 over 3 to the negative 2. That's not simplified because there's negative exponents. The next step is to make the terms with negative exponents cross the bar. I see the 2 has a negative exponent. When it crosses the bar, it becomes positive. The 3 also has a negative exponent. When it crosses the bar and goes upstairs, it becomes 3 squared. You're welcome to leave it like this, or you can write 9 over 4. Take a minute to explore what that negative exponent does to the fraction in number 4. Welcome back. The next problem is an exercise in attention to detail. I'm looking at something that's complicated with a lot of moving parts. If that ever happens to you, it's a good idea to take and look at each thing individually. I'm going to first look at the numbers, then I'm going to look at the A's, the B's, and the C's. And if I keep them separate, I'll be able to keep track of them. I'm looking first at the numbers. I see a 2 on the top and a 10 on the bottom. 2/10 reduces to 1/5. I won't write the 1 unless I really need to. A cubed over a cubed, that cancels out altogether. Anything over itself is always equal to 1. The next thing I see are the b's. There's only a b with a negative 2 in the numerator. There's nothing in the denominator. So I'm going to have this b cross the bar. And when the exponent crosses the bar, it becomes positive. The last item is the c. It's in the denominator. It's also going to cross the bar and become positive. And we have our answer. I see the numerator is c squared, and I see the denominator is 5b squared. Pause the video and try that problem that's identical. Welcome back. The next problem, number 5, has an interesting exponent, a 0. Let's think about that for a minute. We're focusing on negative exponents. Do you see this problem that I wrote? I'm going to write this problem as if it's not a fraction. I can take that denominator and bring it upstairs. When I see two bases that are identical, I know that I can combine the exponents. This becomes a to the 0. So we started with anything over itself is equal to 1, and we explored the exponents, and now we know when we see a 0 exponent, it will always be 1. Just like the skill above, I see a 3 with an exponent of 1, a 0 exponent that reduces to the number 1, and y with an exponent of 1. Our final answer is 3y. Note the 0 exponent doesn't reduce to an exponent of 1. The entire term becomes a 1. Take a minute to try number 5. Welcome back. I'm looking at number 6. I see a negative exponent, so the first thing I'm going to do is write a fraction bar. X to the squared is a positive exponent. It stays stuck. That negative 4 exponent, when it crosses the bar, becomes positive. I'll put a 1 as a placeholder in the denominator. Remember, we can never have zeros in the denominator. I see two terms with the same bases. This has 2 x's, this has 4 x's. The final answer, x to the 6th. Take a minute to try that problem. Welcome back. Number 7 is something that's cubed. The definition of a cube means something times itself 3 times. Don't say the word distribute. That is a term reserved when there's addition and multiplication in the same problem. 10a to the 8th is multiplied by itself 3 times. The answer will take the form of a number and a raised to a variable. That looks like 3 things multiplied together, but really there's a multiplication symbol between the 10 and the a. It's really 6 things multiplied together. 3 of them are numbers. Let's start there. 10 times 10 times 10, 1,000. Now I have 8 a's and 8 more a's and 8 more a's again for a total of 24 a's. The answer to number 7 is 1,000 a to the 24. Take a minute to try your number 7. Welcome back. I'm looking at number 8. It's 2 things multiplied together. Remember, distributing has to do with adding and multiplying mixed together. This is just a lot of things multiplied together. So there's nothing to distribute. This is 3 times x squared times 6 times x cubed times y to the 4th. The form this answer will take is a number, x to some power and y to some power. Let's look at each part individually. If we start on the numbers, I see a 3 and a 6. That multiplies together to give me 18. As far as the x's go, there's 2 and 2 more. That'll give me 4 altogether. And the y's, there's just 4 of them. Our final answer is 18x to the 4th, y to the 4th. Take a moment to see if you can do that problem. Welcome back. Problem 9 is an exercise in reducing fractions. Let's look carefully at this. I'm going to write it out the long way this first time. I see an x in the numerator multiplied by a factor of y. In the denominator, there's 3 factors of x and 4 factors of y. Remember, x represents some mysterious quantity. If you wanted to substitute your favorite number in for x, you could pick something, for example, 5. That would be 5 over 125. That fraction reduces because the numerator and denominator have a common factor. So let's reduce those common factors. And let's write what's left. I see everything that's left happens to be in the denominator. I see 2 x's. Exponents were invented to make things a little easier to write. I see 3 factors of y. And I'm almost done with this problem. I want to make sure I express that that answer is in the denominator. So I use the multiplicative identity to save for the numerator. Remember when you always used to think about 1x, and then you got to a point in your algebra career where you stopped writing 1x and you just wrote 1. Well, that 1 never went away. The multiplicative identity acts as a placeholder in this fraction. The answer to this question is a very, very, very small number, 1 over a large number. If we forgot to put the 1 in, our answer would be way off. You go ahead and try the next problem. Welcome back. Number 10 is a problem where we're cubing again, but the skill we're looking at here is to make sure we can cube a negative number. Like I did before in an earlier problem, number 7, I'll write it out this time, just so we know what we're doing. Negative 2 times x times y squared times negative 2 times x times y squared times negative 2 times x times y squared. We talked about this a long time ago, but maybe we should remember again what happens. Our answer will be in the form of a number, x to a power, y to a power. Let's focus on the number. 2 times 2 times 2 is 8. That's the number part of the answer. But the sign part of the answer is a little bit different. A negative times a negative is a positive, and a positive times a negative gives us a negative. So maybe you're recalling that if you have a negative number raised to an odd power, the answer will always be negative. Now let's work on the exponent for x. I see an x here, an x here, an x here, a total of 3 factors of x. I write a 3 in the exponent to represent 3 factors of x. Let's look and see how many factors of y we have. 2 and 2 more, and 2 more for a total of 6. Our final answer is negative 8x cubed y to the 6th. Take a minute to raise that negative number to an odd power. Welcome back. The last problem, problem number 11. I want you to remember that anything over itself is always equal to 1. At first, this looks like that might be equal to 1, but you see those are not identical terms. They're not clones. 1 is positive, 1 is negative. So let's remember when we see a negative exponent, our first step is to draw a fraction bar. Somebody's going to cross that bar. X to the 7th remains in the numerator because it's positive. That x to the negative 7th in the denominator crosses the bar and it becomes positive. This is a good chance for me to give you an A or B. A or B. Multiple choice. Is the answer going to be x to the 14th, or is the answer going to be x to the 49th? A or B? Think about it for a moment. Going back to the problem, 7 factors of x and 7 more factors of x. The answer will be A, 14 factors of x in total. Take a minute to do problem 11. Welcome back. Well, that was a great job on the Exponent Practice Gateway. If you have completed these problems, be sure to either snap a picture of your notebook and load it up into Google Classroom, or else, if you've downloaded a sheet onto your computer and you've typed in the answers, you're a star at Microsoft Document Equation Editor. Those are tough to type in. Upload it into Google Classroom. We'll take an Exponent Gateway tomorrow on Friday with the exact same problems in a different order with different numbers. If you can do this, you're doing just fine. If you need help, reach out to a friend or reach out to me. Great seeing you. Okie dokie. Bye-bye.